Welcome to 8th in the series of videos on current electricity. In this video, we will analyze how to look into a parallel circuit. So before we do that, let's build up some perception on how to visualize parallel circuit by taking a simple circuit. So here you have a 6 ohm connected to 3 ohm, and you have a battery which is, let's say, 9 volts. So we have these resistance, and it is going to draw some current from this battery I. So before we analyze this, let's imagine this battery produces 2 coulombs, or rather it's producing a lot of coulombs. Now for every coulomb it produces, there is 9 joules per coulomb, and then there is another 9 joules per coulomb. So you have A, B, each of these are 1 coulombs, and it may be doing it in a lot of period of time, but doesn't matter. And some of these coulombs may go through this, and some of these you can visualize would be going through this. But it's quite evident that for every coulomb that passes through these resistors, the energy available is only about 9 joules. So I can say that the potential drop across this will be 9 volts, and the same will be across the 6 ohm, because it's the same, the A or B, both of them have 9 joules per coulomb, and if you assume them as 1 coulomb, then 9 joules. So for this reason, usually the first rule in parallel circuit is the potential drop across parallel resistors is a constant, are same. In other words, the way you can draw your potential diagram is, hey, you have 9 volts gained by the battery, and both your 6 ohm and 3 ohm are going to have a drop of 9 volts. So both your this is your let's mark this as R1 and this is R2. So your R1 and R2, both R1 and R2 are going to have a 9 volts drop. So now the question is, what will be the current? What is going to be the current in this, and what is going to be the current in this? Is there a way to find out? Of course, yes, because in this resistance of 6 ohms and 3 ohms, the Ohm's law applies. So let's assume that this is I1, which the current is going, and this is I2, which it will draw. Right? We know that from Ohm's law, I1 will be equal to V by R1, which is equal to 9 divided by 6, or this will be 3 by 2 amperes. So the current drawn I1 will be 3 by 2 amperes, and the current I2 would be again V divided by R1, and V is 9 volts divided by R1 or R2. R2 is 3 ohms. That will be equal to 3 amperes. So you have these two as values, and the net current I will be equal to I1 plus I2. So if you have certain amount of coulomb that is coming here, and it's going to split up as I1 and I2. So here we know that the net current drawn from the battery should be I1 plus I2. So your I is I1 plus I2. That would be equal to 3 plus 3 by 2 amperes, or that's equal to 9 by 2 or 4.5 amperes. So that's going to be your net current that you will draw from the battery. So that's how you analyze parallel circuit. Just like we did in previous exercise for series, let's see if we can generalize this idea. So you have R1 and R2. You have a battery. Our objective is to find equivalent resistance such that it draws same current from E, the same battery. So that's our objective. So let's draw our objective. We need to find an equivalent resistance such that it draws the same current I, from the battery. So we know that this current is going to split up into I1 and I2. So this is the way the current is going to split up. And we also know that your I will be equal to I1 plus I2 in this particular case. And on here we know that E is equal to I into R equivalent, or your I will be equal to E by R equivalent. So this is your first inference. On left hand side you can say, hey, my I is equal to I1, and I1 is nothing but this potential difference across these two ends are going to be E. So I1 is going to be E by R1 plus E by R2, applying Ohm's law. So this is your second inference. Equating your first and second inference, we can say equating 1 and 2, you have E by R1 plus E by R2 is E by R equivalent, or you can say, hey, 1 by R1 plus 1 by R2 is 1 by R equivalent. Now this is how you find the equivalent resistance for parallel circuits. Now let's see how you can use this idea in a problem. So let's take a case. You have 5 ohms and 15 ohms in parallel. This is connected to ohms. This is connected to 5-volt battery. So what do? So you first, let's draw the potential diagram. That should be the first thing we should do. So that's 5 volts, and the drop for both R1 and R2 will be equal to 5 volts. This is your R1 and this is your R2. To find the current I, we can say that I would be equal to E divided by R equivalent, and my R equivalent I can find out by this equation, 1 by R1 plus 1 by R2. Now this is equal to 1 by 5 plus 1 by 15 that will be equal to 4 by 15. So my R equivalent is 15 divided by 4 ohms. In other words, my I will be equal to E by R equivalent from the top. Oh, that's written there. So let's start from there. This is equal to 5 divided by 15 divided by 4. That's equal to 4 by 3 amps. So that is your net current. So your net current is 4 by 3 amps. You can also find what will be your I1 and I2. You know that your I1 is going to be E by R1, or in other words, that's 5 volts. The drop here will be 5 volts. So you can say that's 5 by 5, that's 1 amperes. And through this, I2 will be equal to E by R2. That's equal to 5 by R2 is 15. That's 1 by 3 amperes. And what is interesting is, if you add I1 plus I2, that's equal to 1 plus 1 by 3, that is 4 by 3 amperes. That's exactly what you have got by earlier calculation. So I hope you enjoyed this video. I would urge you to try to solve this problem yourself once, to get to grapple this in your head. If you get stuck, you go back to the videos and refer again. So see you until the next video. Bye.